Okay, so when we look at our parameter notation, now we're using mu1 minus mu2 because we're looking at means, so our quantitative parameter becomes mu. So this, if we think about our parameter of interest, is looking at the difference in true mean for group 1 minus the true mean for group 2. Okay, thinking about what we're studying.
Okay. And so like the true mean would be just like the long run proportion, so that would be like the simulated
Here
null.
we, so a long run and true, my pen's not working good. Long run and true basically mean the same thing. So this is going to be about our population, what we want to know about our population.
Okay, cool. I guess like one thing I'm kind of a little confused on is like how would we get like the true mean if we are just given like a like the results from one statistic or whatever, or
Right.
one
So we
test.
never really know what the true mean is because we would have to have an entire population that we could measure. So we're
Okay.
going to do a couple things. We're going to test to see, does our statistic make sense? Does it differ from the value of 0? So we're going to use the difference in sample means and see if that can give us evidence against our parameter, or sorry, against our null hypothesis of 0. And then we're also going to estimate this parameter by finding a confidence interval.
Okay. All right.
Okay. So the parameter never has a value because if we knew, my joke that I always say is if we knew parameters, you wouldn't have to have this class because we wouldn't need to have statistics. Okay.
Sorry, you cut out just a little bit there. Could you say that one more
I
time?
cut out?
Um,
I think you need to tell the kids get off the computer. So what I said, my joke is that if we knew parameter values, we wouldn't need to have this class because we wouldn't need to know statistics because we'd already
okay.
know everything about the population.
Okay. Okay. I catch. I got it.
So our statistic notation then is going to be x bar 1 minus x bar 2, which is looking at the sample mean for group 1 minus sample mean for group 2. We'll have that because we calculate that from our samples. All right, so when we look at a simulation test, we're simulating the null based on the assumption the null is true. So our null for a difference in means, we're going to assume that those true means are equal, or we could also talk about it as the two means, the difference in two means is equal to 0.
Okay. Cool.
For the alternative, we're going to use our research question to look at, is it greater than, not equal to, or less than? We're going to use that research question to assess that direction. So if the research question says we want to see if there's a difference, so one of the explorations we looked at this week was the difference in true mean number of close friends for men and women. There we're just trying to see, is there a difference? So it'd be a two-sided test. So we'd use not equal to.
Okay. Cool.
If we wanted to see that women have more friends than men, then we could look at greater than. The true mean number of close friends for women is greater than the true mean number of close friends for men.
Sweet. Got it.
Okay. Okay, if I go to the next page.
Yeah. Do you mind if I screenshot this really quick, just for
No,
reference?
it's fine.
Sweet. Awesome. Yep. I'm ready now.
Okay. All right, so we create our simulation and find then a p-value. And so we can kind of we'll work through an example. I have a worksheet that we can look at on Google Drive that we can kind of talk about how we use the simulation.
Okay.
But essentially we assume the null is true, we create a simulation and find our p-value based on our sample statistic.
Okay.
And conclusions, interpretations of p-values, those stay the same as what we've looked at all along.
Sweet.
So if we think about theory-based inference, this is where we're looking at formulas. So this is going to be your section 6.3.
Okay.
And for theory-based inference, we use the t-distribution instead of the standard normal distribution when we have quantitative variables. So we're going to use a t-distribution for this study. And our standardized statistic changes a little bit. To find our standardized statistic, we're going to use the statistic, the difference in means, minus the null again, which again is 0 because there is no difference in the true means. That's what our assumption we're making.
Okay.
And then divide by our standard error for the difference in means.
Okay. So that 0 represents the null then?
Yep.
Okay, cool.
And when we have standard error, this means standard error of the difference in means. This isn't multiplication. It's going to be one value that we're going to calculate from this equation.
Okay.
So we have S1 squared divided by N1 plus S2 squared divided by N2. So I'll define what those are.
Okay, cool.
S1 is the standard deviation for group 1. So it's a sample standard deviation for group 1. And S2 is the sample standard deviation for group 2. And then those sample sizes, N1 and N2, are the sample sizes for each group.
Okay, cool. And would we be given the standard or like the sample standard deviation, or is that something we have to calculate?
Yeah, so no, no, you will not need to calculate it. It will be given to you either in the applet output, or we'll just say this is the sample mean and this is the sample standard deviation for this group.
Okay.
Okay.
Cool. Awesome.
All right, so that kind of takes us through the standardized statistic. So let's talk about validity conditions really quick, because they're a little different when we think about quantitative data. So for quantitative data, if our sample size is less than 20, then the sample distribution must be symmetric. If the sample size is greater than 20, then the sample distribution cannot be strongly skewed.
Okay.
And this has to be true for both groups. Okay.
Sounds good.
Okay, so then we'll move on to our talking about a confidence interval.
Okay.
Did you already get your screenshot?
Yep, got it.
Okay. All right, so then to find a confidence interval for the difference in means, we're looking at, whoops, jumped quantitative data again, or categorical data. So now we're looking at our statistic x bar 1 minus x bar 2, because we're measuring the difference in means, plus or minus the multiplier times the standard error for the difference in means. But the good news is this standard error is the same equation that I gave you on the previous page.
Okay, awesome.
Okay. So anybody have any questions on these things, or we can work on a couple examples?
Yep, examples are great.
Okay, are you good, Gabe?
Yep, I'm good.
All right, so I'll take us to that. Which I thought I had open and it looks like I don't. So let me grab that really quick. So this is the review that's posted in the Google Drive. Which for some reason I don't have. Let's see if I can get that to download really quick. All right, we should be good now. Sorry, I wasn't fully prepared, I guess, there. Oops. All right, so we got our sheet here showing this exploration or covering these explorations. All right, so we're looking at memorizing letters. So people can people better memorize letters if they are presented in a recognizable grouping? If they're not, class where the subject is a question, in 20 seconds. So USA. The other students were given the exact same letters in the same order, but the groupings varied in size and did not include examples. The instructor 20 seconds of studying. It's like my sound's going. Hang on.
Yeah, it's a little bit in and out.
I've learned that it works better with my headphones. Can you guys hear me now?
Yep, sounds good.
All right, so after 20 seconds of studying the letters, the students recorded as many letters as they could remember. Their score is the number of letters memorized correctly before their first mistake. So the instructor conjectured that students in this recognizable group would memorize more letters on average than those in the unrecognizable group. All right, so let's think about what we are looking at here. So we're identifying the role of each of our variables. So the type of grouping, whether it's recognizable or unrecognizable, would that be our explanatory variable or our response variable?
Explanatory.
Sorry, what'd you say?
Explanatory, right?
Yep, it's our explanatory. Those are going to be the two groups that we're comparing. Is that a categorical or a quantitative variable?
Categorical.
Yep, categorical. So then we're going to measure the number of letters memorized. So that's going to have to be our response variable. Is that categorical or quantitative?
Quantitative.
Okay, so we're going to look at the difference in mean number of letters memorized for the recognizable group and the unrecognizable group.
Okay.
So when we're thinking about our alternative hypothesis, this means that the true mean number of letters memorized has some sort of relationship between the recognizable group, we'll say that's group 1, and our group 2. Are we trying to show that one group is higher than the other based on our alternative, looking at our research question, or are we trying to just measure a difference?
It's higher than, right?
Yeah, they want to know, does the recognizable group have a higher mean number of letters memorized than the unrecognizable? So which of these three options would represent our alternative?
Looks like it would be D, right?
I agree, D. So we're looking at that long run or true mean number of letters memorized in the recognizable group is higher than in the non-recognizable group. So in our applet, we could paste in the data. This was already done here, and we can see down here all our summary statistics. So this is where we would get all those values. So if we think about we're going to just ignore pooled. We're never going to use pooled in this class. So our recognizable group, that's going to be our group 1, and the not recognizable group is going to be group 2. So just to kind of jot down some summary stats here, we know the sample size for group 1 is 26. The mean for group, sorry, not for group 1. Let me fix that. It's 25. The mean for group 1 is 14.32. And the sample standard deviation for group 1, that's our S1, is 8.5. I say 8 and write 6, 8.52. The sample size for group 2, which is the non-recognizable group, is 26. The sample size for group 2, or sorry, the sample mean for group 2 is 11.15, and the sample standard deviation for group 2 is 6.58. Guys following where we found all those different values?
Yep.
Okay. But what does this observed difference down here represent?
Would that be just the difference in proportions?
Difference in means.
Oh, difference in means. Okay.
So that's going to be X bar 1 minus X bar 2, because this is quantitative data.
Okay.
So that's looking at the 14.32 minus the 11.15.
Sweet.
Okay. All right. So what do you guys think about the shape of each of those distributions? So we've got these two distributions up here showing a box plot and a dot plot. Do you say that they're both roughly symmetric, or do you think that one's skewed over the other?
I would say the top one is definitely more skewed to the left, but they both seem a little bit skewed to the left.
Yeah. So to be left skewed, we'd have to have more data on the right-hand side. So left skewed distribution would be more like that.
Oh, so it's right hand skewed then?
It could be a little right skewed. I think that looking at this data though, it's probably fairly symmetric.
Okay.
This is where we can kind of get away with being like, oh yeah, that's kind of roughly symmetric. So I'd say both of those distributions are roughly symmetric.
Okay.
So notice that the wording, it says strongly left skewed and strongly right skewed. So
Okay.
if we had a strongly skewed distribution, it would look more like that.
Okay.
Okay.
Got it.
So these are both roughly symmetric. All right, sample statistic, that's what we said was the X bar 1 minus X bar 2, where we're saying that 1 represents the recognizable group and 2 is the non-recognizable. So that's taking, we know that difference is 3.166, but we could also find it by taking the 14.32 minus 11.15.
Sweet.
And that is rounded, so 3.17, so it's close to what we saw for that observed difference. So this next question is getting at that idea of validity conditions. So it's saying, would the theory-based methods give us the same p-value as for simulation methods? So remember, we need to look at our sample size and see, are those greater than 20?
Mm-hmm.
And they both are. And then we'd have to look at the shape of the distributions. And we said that they're both roughly symmetric, so they're not strongly skewed. So yes, the sample sizes are both greater than 20. We have 26 and 25. And the sample distributions are not strongly skewed. Any questions so far?
Makes sense.
Okay. So to find that standard error for the difference in means, this is looking at theory we're taking the square root of that sample standard deviation for group 1 squared divided by its sample size plus the sample standard deviation for group 2 squared divided by its sample size. And we had those values given up here. So we have the 8.52 and the 6.58, and then our two associated sample sizes, 25 and 26. So we're just going to plug in those different values. And once we sum those values together, you would take the square root of that number. And that's probably one of the most common, there's two common errors that happen. One, students forget to square the sample standard deviations, and then they forget to take the square root. So this would be a sample standard error for the difference in sample means of 2.137.
Is there a way to kind of like immediately know if you forgot to do one of those two things? Like does the standard error always kind of sit between -10 and 10?
Unfortunately not. It's never going to be a negative number. I can tell you that for sure.
Cool.
One thing that we could look at right here, and I have my null distribution, it should be pretty close to the null standard deviation.
Gotcha.
Because that value is, as long as we've met our validity conditions, those would be approximately the same value. So that's kind of a double check. When you're calculating the standardized statistic, if you get like a really huge number, like 32 or something like that, my guess is you forgot to take the square root of your standard error. So doing the next step might clue you in on that. All right, so now we're going to calculate that standardized statistic. So we're going to take our difference in means, which we found up above. I can write -0. Obviously, that's not really necessary because mathematically it's not doing anything, right? And then I'm going to divide by that standard error we just calculated. So my difference in sample means I have up here as 3.17. And now I'm dividing that value by 2.137. And that's 1.48. So this standard error, or this standardized statistic, is measuring how far x bar 1 minus x bar 2, so that 3.17, it's measuring how far that value is from 0 in measures of standard errors.
Okay, cool. And is this standard error assuming that the null is true, or is that the categorical one?
So with the category, we don't have to worry about the standard error assuming the null is true with quantitative data.
Okay.
It's the same calculation regardless of whether or not we're assuming the null is true or not.
Okay, cool, awesome.
All right, so what this tells us then, and when we interpret this value, is that the sample difference in mean number of letters memorized in the recognizable group minus the non-recognizable group of 3.17 is 1 point. I got to write the right value. The 1.48, that's my standardized statistic, standard errors Would it be above 0 or below 0?
Above.
Yeah, because this value is positive. So I can think about the fact that I know that this standardized statistic of 1.48 is not very large. So this is probably not going to provide a very large p-value. It's showing little to no evidence against the null. And we'll talk about other ways that we can see that in just a second. One thing that we know is that roughly 95% of values are within 2 standard deviations from the null value. So when we have a standardized statistic that's less than 2, it's not going to provide much evidence against the null. It's just kind of some general rules of thumb here. All right, so to calculate our confidence interval, we're going to take the difference in means, not differences in proportions, plus or minus the multiplier times the standard error. So this difference in means here, we already calculated up above and we know is 3.17. We're going to use the multiplier given in the problem. And we're going to use that standard error that we found previously as well, the 2.137. And this gives me 2 endpoints, negative 1.241 to a positive 7.581. So looking at this confidence interval, how do we know that we have little to no evidence against the null using the confidence interval?
Is it because 3.17 is like in the middle of it, or is it because the 1.48 doesn't even reach 2?
Okay, so the 3.17 is always going to be in the center of the interval because I used it to create the interval.
Oh yeah, of course. Yeah.
The 1.48 is telling us we have little to no evidence against the null, but what about the confidence interval is telling me I have little to no evidence against the null?
Weren't both of the X bars like 14? Does that have anything to do with it or no?
No, it has to do with the fact that in our null, we're going to assume that the difference in means is equal to 0. Is 0 in my interval?
Yep.
Okay, so when 0 is in our confidence interval or the null value is in the confidence interval, that says, hey, we really don't have evidence against the null because it's plausible that that difference is equal to 0. That makes sense to you guys?
Yeah, it does.
Okay. All right, so let's talk about interpreting this confidence interval. So we are 95% confident because we've created a 95% confidence interval. And when I think about a confidence interval, I want to think about that relationship between mu1 and mu2. So I know that the difference between mu1 and mu2 based on my confidence interval could be between negative 1.241 and positive 7.581. So I'm going to talk about the true mean for group 1 in relation to the true mean of group 2. So we're 95% confident the true mean number of letters memorized in the recognizable group, my group 1, is 1.241 letters less to 7.581 letters more, my observational units letters, than for the unrecognizable group. Does that make sense? How we're putting in that order of subtraction there?
Yep.
Okay. All right, I want to go back up for a second. We'll get to the idea of scope of inference in just a second. But we haven't talked a lot about simulation here. We talked about the fact that we simulate 1,000 simulations based on the assumption the null is true. If I wanted to find a p-value from this output here, what would I do?
We'd have to count samples, but I'm not.
Okay, yep, we're going to count samples.
From our difference, right?
What value do we want to count from? What's our statistic?
Would it be one of the means?
So it's not going to be just one of the means. We're going to use that x bar 1 minus x bar 2.
Yeah, so
Oh.
it's 166.
Yep, so we're going to put this value right here. What direction do we want for our to count here?
Greater than?
Yeah, and that's based on what?
Based on the question and the not the question, but the idea, the alternative hypothesis based that it'll be greater when they have numbers in a sequence like FBI or CIA.
Right, right. So it is based on that research question and that alternative hypothesis. So if I estimated on this graph, I could circle this area right here saying, all right, I'd be counting the number of observations or simulated samples at 3.166 and greater. So we can see that that simulation p-value would be pretty large, kind of like we were seeing with the fact that we got such a small standardized statistic. You guys following that okay?
Yep. And then what applet was used to create this
Multiple means.
multiple means? Okay, cool.
Yeah, you'll need that for your study you're looking at today with the bouncing heights of the tennis balls.
Okay, cool. Sweet.
Any other questions on that so far?
Nope.
All right, going back down here. So these last two questions are talking about scope of inference. If I can spell inference. So the first question is getting at the idea of cause and effect or causation. So could we talk about causation in this study? What do we have to have in order to talk about causation?
Would it be randomized, randomization, I guess?
Yeah, we'd have to have randomization. So we'd have to randomly assign the individuals to the explanatory variable group, which was either recognizable or non-recognizable groupings. Do we have random assignment?
No.
Don't think so.
Nope, yeah, we do. Yeah, right after the ... the instructor decided which students received which grouping by random assignment. Yeah.
Okay, so we do have random assignment, so we can talk about causation. All right, so yes, we could talk about, we'd be justified in saying that there's a cause and effect relationship because they used random assignment. To letter groupings. Can we generalize to a larger population?
Okay.
I guess it would just depend on whether or not it was a representative.
Right.
Which it wasn't.
Nope, it just says students in an introductory stats class. It doesn't say that they used random selection at all. They were probably just volunteers. So this is an example of a convenient sample. So we can only apply or only generalize to those similar to the students in the study. Because this was not a random sample. Good. Any other questions over either simulation or theory-based tests for difference in means?
Don't think so.
Okay, did that help, Gabe?
Yeah, that filled in so much. That was actually incredible. Thank you so much for all the help.
Sure, no problem. How about you, Taylor? You all right?
Yep, all good. Starting to think forward about studying for the final. Do we know what the format of that is going to look like?
So what I do know is it's going to be on Gradescope.
Nice. Okay.
There will be some questions where you'll have to use the applets because we obviously can't tell you not to open other screens or anything. So we're going to take the advantage of the fact that we can have you use the computer. So you'll be using the applets in some cases and creating, and that some of the questions, it'll be like kind of like one of the quizzes you've been doing. It'll be really similar to that as far as format. It is cumulative, but it will focus primarily on the end, this last couple of weeks of material since the last exam. So pretty much everything we've done since we've been quarantined, but there'll be some questions definitely that will encompass the entire semester.
Okay.
I think the plan is we'll open it for like a 2-day period of time. So like it'll open, I'm making these numbers up, so don't be like, you said, but like it'll open like on a Tuesday morning and close on like a Wednesday night or something like that.
Okay.
Once you start the exam, so once you start taking the exam, you'll only have 4 hours to complete it.
Only 4 hours. Okay.
Well, and I mean, so it's written for it's going to be written very similar to if we were having it in class where you'd have 2 hours. But one of the things that we're trying to also keep in the mind is that as you're working on things, especially if you have to take screenshots and save them, is you want to make sure you have ample time to do that. So no, it shouldn't take you 4 hours to complete it. But the goal is there that if you have any problems, like if you're going through and you're like, man, I can't get these screenshots to load or something like that, you're not like stressed because I'm out of time and I didn't get half the questions answered. So I'm not sure. I mean, I'll have another study session next week for review for sure. They're recorded as well. So if you're ever like, hey, I missed it, you can go check out those recordings. And then also, I imagine they're going to do they'll be in-class review as well on the Thursday and Friday before the exam. And then I don't know if there's going to be a large section review. I'm not sure what that would look like, but hopefully we'll have some information soon about that.
Cool. Sweet. How do we access your recordings?
So I actually have a YouTube channel. So if you, in that email that you probably used to get to me today, there's a Google Drive folder, and then there's also a YouTube channel linked in there.
Okay, awesome.
So
Sweet.
obviously this recording's not there yet since we're still recording, but it'll be there by later tonight. So.
All right, awesome. Thank you so much.
Yep.
Cool. Yeah, super appreciate it. Thank you as always.
All right. We'll see you later.
Take care.
Have a good one.